Um, and what a proof is, it's just a logical argument that shows a statement is true. So that's all it is. It's you trying to explain why something is true. It's no different than writing a paper in English class. So no different than debating with a friend. Okay? It's just explaining why something is true. How we set up our arguments in geometry is we use something called a two-column proof. Okay, there's two columns, look something like this. Okay, one side is statements, the other side is reasons. So the left is statements, the right is reasons, and they're numbered. So you're listing out these statements, which are statements of things that are true, and your reasons are why they're true. Okay? So a statement is like saying, this thing is true, your reason is because of this. That's kind of what each line is. Okay? So we go back here. So it's a two-column proof are numbered statements with corresponding reasons that show an argument in a logical order. It's also really important. It has to go in order. Right? You're explaining to someone how to make a sandwich, you wouldn't explain to them the steps out of order, right? It wouldn't make it very easy. So, same thing with proofs. You have to go in a logical order. You have to go in order. Valid reasons, things we use for reasons, things we use to back up why we think something is true, are definitions. Theorems, and postulates. Postulates and these things called properties. You'll often see these things as your reasons. We talked about postulates at the beginning of the year and theorems at the beginning of the year. The definitions of words, or types of angles, postulates, theorems, properties. These are what we use. When we write a proof, the given information goes first. The given information always goes first. What you're trying to prove will always be last. Right? So the last statement will always be, and this is a typo that I didn't fix apparently. This should be will. Always be what? You are proving. What's the proof? What we mean by that, fast forward to this. You'll have a statement that says given. Whatever is next to the given always goes in the first statement box. Then you'll have a word that says prove. Whatever's next to that is always your last statement. I like to call them freebies. Right? Whatever's with the given goes in the first spot. Whatever you're trying to prove always goes in the last spot. Every single time. That should be your first step. And if you recall from the beginning of year, postulates are rules that are accepted true without proof. Right? They're just kind of like those no-brainer statements. Oh yeah, like there's no argument against it. It's just accepted true. Theorems are those things that you have to explain why they're true. So, like the linear pair angle theorem, or the angle sum theorem from the beginning of the year. They're all the angles of a triangle add up to 180. Or two angles that form a linear pair add to 180. Or vertical angles are congruent. Things like that, we had to show that were true. Those are theorems. Okay? Someone sat down, made some diagrams, did some explanation, and said, hey, this will always be true. And that's what makes them theorems. Okay? There are many things we can prove in geometry. Okay? Right? theorems I just stated, the angle sum theorem, linear pair angle theorem, vertical angle theorem, those things we talked about at the beginning of the year, there's proofs to show why those are true. Okay? There's other proofs that we can do in geometry involving showing that triangles are the same, that triangles are congruent. But we are really only going to focus on parallel line proofs. Okay? So, in order to be able to do a parallel line proof, we need to review parallel lines. It's been a while. We did all the way back in Unit 2. We saw a little bit of it if you've been doing those OST reviews. We got to do a little bit more review now because it will help us with our proofs. And essentially when we do parallel line proofs, we're just trying to show that two angles are congruent. Okay? So it's good to review those theorems and those terms back from Unit 2. So if you remember corresponding angles, right? That states if two lines are parallel and cut by a transversal, then the pair of corresponding angles are congruent. Okay? So I like to think corresponding angles are sitting in the same corner. So I'll just give one angle. I'll give angle 1. Which angle in this diagram is angle 1's corresponding angle? Which one's sitting in that same corner? Think if you make a box here, a box here, which one's sitting in the same corner as angle 1? 5, right? So angle 1 is congruent to angle 5. They're corresponding. They're sitting in the same corner. So now erasing those boxes. What is angle 2's corresponding angle? 6. Yep. What's angle 4's? 8. Very good. What's angle 3's? 7. Very good. Those are corresponding angles. They are always congruent to each other. The next one is alternate interior angles. Those are also congruent to each other. And remember, alternate interior angles are inside and opposite. So looking at our diagram, what's a pair of angles that are inside and opposite? Well, 3 and 6. 3 and 6. Good. What's another pair? Caitlin? 4 and 5. 4 and 5. Those are also congruent. Same side interior angles, and again, I didn't catch this. We used this consecutive a long time ago, and I don't know why I didn't change it. Same side. That should be same side interior. Same side interior are a little bit different. Same side interior are on the inside and the same side, but they add to 180 degrees. We don't really use these as much for parallel line proofs, but it's good to review. Who can give me a pair of same side interior? 3 and 5. They're inside and on the same side, and they add to 180. Pulling at my board. Again, we don't really use those as much. There are some parallel line proofs that involve them, but we kind of focus on angles that are congruent. And lastly, alternate exterior angles. Right? Those are outside and opposite. So you can give me a pair of exterior angles. Yes. 1 and 8. Perfect. 1 and 8. Very good. And what's the other pair? You just shout it out. 2 and 2. And knowing those and being able to identify what type of angles you have is really important for these proofs. Okay? So if you can identify if angles are alternate interior, if angles are alternate exterior, and if angles are corresponding, you're going to be fine. Okay? That's the big thing, is to be able to identify these angles. And an important property that we are going to use with parallel line proofs, again, there's tons of properties, Maybe talked about them Algebra 1, maybe talked about them 8th grade, 7th grade math. It's called the transitive property. And the formal way of the transitive property, it just says if A equals B and B equals C, then A is going to equal C. Essentially what the transitive property does is it links three things together. Okay? It linked A to B. Then we linked the second thing to a third thing, B to C. So if the B is in both, that means A and C are also linked together. You're just linking three things together. The main thing to remember is, okay, the last reason in a parallel prime proof will always be the transitive property. Every single time. So we have three freebies. You're given information's first statement. What you're trying to prove is your last statement, and the last reason is always transitive property. Every single time. Because that's what we're doing with parallel line proofs. We're linking three things together. You're going to be given two angles. You have to link one of them to a third angle, and then that connects the last angle. Okay? So when we do a parallel line proof, we're just linking three things together. Another way to think of a transitive property is using like a sports analogy, right? If Hayes beat Buckeye Valley, and Buckeye Valley beat Olentangy, what is like the logic be? Well, then Hayes would beat Olentangy, right? Have you heard that in sports? That's kind of what transitive property is, just linking three things together. Okay? But the main thing is just know it's the last reason in a parallel line proof. Okay? And these are not bad. Like it might seem overwhelming right now, but once we do our first one, it's the same pattern every single time, and you're eventually going to be given a word bank, and that helps a lot. Okay? But we're going to try them without the word bank and then kind of ease into that. Right? So, we want to show that angle 3 and angle 6 are congruent. Knowing that A and L is parallel. You might be thinking, well, I know they're congruent. They're alternate interior angles. I know they're congruent, right? But we have to pretend like we don't know that. We have to pretend like we have to explain this to someone why they're congruent to each other. Okay? It's kind of what you're doing with a proof. You have to act like you don't know that those angles are congruent, and you're explaining to someone why they're congruent. We can't just jump to that they're congruent. We have to explain why. It's just an explanation. So we said our given goes first. So we're given that A is parallel to M. So that's going to go in this first statement. And it's really nice. Here's another freebie. Your first reason with that is just given. Every time. First thing. First thing. Every time. We said the last statement is what you're trying to prove. And we're trying to prove that angle 3 is congruent to angle 6. Again, we kind of already know that, but we have to explain why. Why are these the same? And we said our last reason every single time is transitive property. Every single time. Every time. Okay? You just have to fill in the middle. Here's how you fill in your middle. Look at what you're trying to prove. Pick one of the angles. I just tend to pick the first one, so it's consistent. You can always just pick the second one. I just like to pick the first one. So I'm going to pick angle 3. Okay? And again, we are linking angles together. So looking at that diagram, I have to pick another angle that's congruent to angle 3. And we don't have a word bank, so it can be any angle. And there's 2 of them. I'll give you a hint. Just has to be one. Looking at that diagram, what's another angle congruent to angle 3? Feeling? Angle 2. Angle 3 is congruent to angle 2. Why is angle 3 congruent to angle 2? What kind of angles are they? Vertical. That's your reason. So when you state that two angles are congruent, your reason's just this type of angle is congruent. 3 and 2 are vertical. So your reason is just vertical angles are congruent. Or if you have a word bank, it's the vertical angle theorem. Vertical angles are congruent. You one of the two. But you're just taking the statement about vertical angles. So they are vertical. Here's kind of another freebie. We're linking things together. So number 3 is just bridging that gap. Okay. So we said 3 is congruent to 2. To connect them, right, whatever this new angle is, or my new angle is angle 2, you just connect it with that last angle. Bridge the gap. So these two just become congruent to each other. So whatever new angle you put, you just take the other angle and say they're congruent to each other. Then look in your diagram. Here's angle 2, here's angle 6. What type of angles are angle 2 and angle 6? Corresponding. And we know corresponding angles are congruent. So you would look in your word bank if there was one, and just say corresponding angles are congruent. And I abbreviate. Don't want to write out corresponding. Too long. And you just did your first. And it's that same pattern every single time. You're just dealing with a slightly different diagram number. But it's the same pattern. Okay? Questions over there? Try another one. Okay, so let's fill this out. What am I going to put in this first statement? What goes first? What information? The given. Very good. A is parallel to M, and our reason with that is always given. What's going to be our last statement? What's going to go here? You shout it out. You prove. Angle 1 is congruent to angle 8. And we said with parallel line proofs, what's our last reason every single time? Triangular property. And then we fill in the middle. Okay? When we fill in our middle, again, I like to pick the first angle. Look at your diagram. I picked angle 1. Give me an angle that's congruent to angle 1. Yes. Angle 4. Very good. Why are angle 1 and angle 4 congruent? They're vertical. And we know vertical angles are congruent. And ignore this. I'm not too worried about that. Because you'll have a word bank and you have to kind of do what the word bank tells you. Angles are congruent. Alright. Now, what has to go here? How are we going to bridge that gap? How do we bridge? Is congruent to angle 8. Bridge the gap. These two, say that they're congruent. Look at your diagram. Why are angle 4 and angle 8 congruent? What type of angles are they? Think angle 4 and 8. 1 and 8 are alternate exterior. Of course. We're trying to prove that alternate exterior angles are congruent. I should remember. I thought it was saying something else. I did not read the directions. And there we go. Same pattern every single time. Not too bad. Okay. Here's one with a word bank. Here's the thing when it comes to word banks. The first two, we can kind of go anywhere out we wanted to go. Okay? Here, we have to kind of use what they give us. You can't just make up your own thing. Because when you ask this question on the OST, they give you a word bank, and you have to click and drag. So you like click, and drag your answer to where you think it's supposed to go. Okay? So you can't just they don't let you type in whatever you want to type in. You have to use what they give you. So when you take your quiz over this, you're going to have a word bank, and you have to use what they give you. I've had students in the past that they did prove it correctly, but they didn't use the word bank. And you just have to get used to whatever they give you, that's what I have to use, because when you take the OST, you don't really get a choice. Okay? You have to use what they give you there. So a lot of the times they fill in information for us. Okay? It's a partially filled out proof. They put our given in, they put our last statement in, we have to fill in the rest. But we know what's our last reason every single time. Here's the property. Then we have to link these together. I like to pick my first angle, angle 3. So I'm going to look at all the possible options that I can use. This has an angle 3 in it. This has an angle 3. That has an angle 3. This was already written for us, so it shouldn't be there. That's gone. Right? We don't use the same thing in a proof. We don't repeat things. So if that's already there, we're not going to use it. So one of those 3 is going to be my option for number 2. Does angle 3 congruent to angle 3 make sense to you? No, you're just linking it to itself. That's not getting us anywhere. So it's one of these 2. Okay? Well, pick one. Which one do we want to use? Do you want to use 3 and 7 or 1 and 3? Just try it out. 1 and 3? Let's use 1 and 3. Sometimes it's going to work. Sometimes you're going to have to go back and use the other option. I used 1 and 3. Why are 1 and 3 congruent? Again, you just shout it out. They're vertical. Vertical angles are congruent. That's a reason, so I'm going to put it there. And we'll use that one. Now, is there a statement linking? What do we need to link? We said 1 was congruent to 3. That means we have to link 1 to 5, right? To bridge the gap. Is there a statement linking 1 to 5? Yeah. So we know we went the right route. If we picked 3 and 7, is there a statement linking 7 to 5? No. So then we know we can't use that one. Okay? So that's why you have to, with the word bank, sometimes you need guessing jump. So the only other option we have is 1 and 5. That's going to go next. Angle 1 is congruent to angle 5. Look at your diagram. Why is angle 1 and angle 5, why are they congruent? Look at your options. We already used, oh, I scratched out the wrong one. That's a typo. It's not in there. Sorry, this should be core. Oh, I know what happened. I think it got hidden under the text box. Sorry. Pretend like it's squeezed in there. I think it got hidden in the text box. Sometimes when you copy a text box over, it like reformats and you lose words. So pretend like that's there. What type of angle are 1 and 5? Corresponding. So you would select the one that was corresponding. And again, you're given a word bank, and we have 2 options. They are either corresponding or alternate exterior. So you can logically look and be like, well, one's outside, one's inside, so they're not alternate exterior. That means you have to be corresponding. And you're done. Yes. That's what? What reflexive? That's another property. We don't use it with parallel line proofs. You'll see it in other proofs, but we're just not going to get to them. Reflexive property. Reflexive property is just something's congruent to itself. So whenever you have two things, the same thing being equal to each other, that's reflexive property. We don't use it for parallel. So the only property we use for parallel versus shifting. So that's what's going to happen on the OST is there's just some proofs we didn't get to. They always ask one like this. And I think these are pretty easy. The other proofs are really hard and we just don't have it. So you might have other proofs and just, see them. Maybe go back to those at the end and find one that looks like this. Just parallel line. Questions over that? Last example here. Here we have double parallel lines, but the process is still the same. Even though there's double parallel lines, it's still the same process. Okay? You're given information first. You're given reason. Given is your first reason. What you're trying to prove is last. And then what's our last reason every single time? Every time. Again, you're going to have different properties and things in the word bank to throw you off. Just kind of ignore the ones that you don't recognize. So now we have to link these angles together. Again, I like to start with angle 1. Looking in my word bank, that's an angle 1. That's an angle 1. Which one do we need to use if we're linking 1 to 11? Are we going to use 1 and 5 or 1 and 15? 1 and 5. Right. Look at your diagram. Here's angle 1. Here's angle 5. What type of angles are 1 and 5? Corresponding. Again, you can go through your list and guess and check. See if they're vertical, see if they're corresponding, see if they're alternate exterior, see which one fits those angles the best, and it's corresponding. All right. What's our next statement? We linked 1 to 5. Now we have to link 5 to 11. The reason why if you did 1 and 15, your next step would link 15 to 11, and I don't see 15, 11 in there. So then you would know that one's wrong. Go back to the other one. So we use 5 and 11. Look at your diagram. Here's angle 5. Here's angle 11. What type of angles are 5 and 11? Are they vertical? Or are they alternate exterior? Which one would make the most sense? Being vertical or being alternate exterior? Alternate exterior, right? Vertical, like 9 and 11 are vertical. 5 and 11 aren't even touching. So it would make sense to me, if I wasn't sure, alternate exterior makes the most sense. And I like to abbreviate things. And there we go. Questions over there? The rest of the time is yours. Work on